pollution control in general can be pretty intimidating. It's pretty complex. The regulations and what you have to meet when you throw it in, as well with, OSHA requirements, it can be pretty daunting. It's important to have somebody that actually understands those regulations, that they understand what's at stake, and that they're going to provide a product that really is going to do what they say it's going to do.
We have exhaust fans, we have scrubber systems, we can provide people with consulting services, we can provide people with incineration systems, and we can provide people with combinations of all of that. And then from a higher level, we can thoughtfully integrate pieces and parts together to give people what they need by assessing their overall process.
Verantis provides pollution control equipment for industrial applications, for the most part in very corrosive environments. Most of our products are FRP, which is fiberglass reinforced plastic, and that's just a much better product to use when you have a corrosive airstream or a corrosive type of application.
What we do better than anyone else is basically we're able to take an application and start to finish offer a complete package for whatever the customer's needs are.
We can engineer, design, and replace an old existing system. There's times we also do retrofits. If they need one of our blowers in an existing system, we're able to design and engineer a retrofit for that as well.
Problems happen in industry, so our ability to send field service techs out right away to either help them analyze what went wrong, we have those capabilities. We have the engineering in-house, we have technicians who have been working with our company for decades, so we're able to send very knowledgeable, valued service techs out to the customer to help them with those opportunities.
You can visually look at our fans compared to other competitors and see the difference if you didn't know anything about a fan. I feel we're the best in the business. Some prefer the better things, some prefer the cheaper stuff, but if you want to last longer, I think you should go this route through Verantis.
Welcome, and thank you for joining us today for Fan Installation and Maintenance presented by Verantis. I'm Mary Rusnak, Marketing Director for Verantis, and with me today are Craig Brackman, our Operations Manager of our manufacturing facility, and Junior Hardman, our Plant Foreman and Fan Guru. While we wait for everyone to join, I'd like to go over some basic information about our webinar platform and the PDH certification that we offer. Our presentation today is very detailed, so I'm going to go through this as quickly as possible so that we can begin. Our webinar platform is completely interactive. All the windows that you see can be minimized, maximized, moved over, whatever works for the screen that you're looking at. A recorded version of this webinar is going to be available later on demand, and all of the interactivity that we're going to talk about remains as well. On the bottom left of your screen is the media player. If you should happen to lose your sound or your slides, this is where you should look first and just make sure you didn't accidentally close it out. Also on the left-hand side, you're going to see the Q&A, and that is where you're going to submit all of your questions. To keep ourselves on track, we're going to hold all of the questions until the end of the presentation, but you can submit them at any time. If we don't get to your question live, don't worry about it. We will get in touch with you and make sure that you get the answer that you're looking for. Also on the left-hand side, you're going to see the resource list. This is basically available for viewing or printing at all times. This is whether you're watching it right now live or on demand later. One item in particular that would be of interest to people who are taking the quiz later on for the PDH is the fan maintenance summary. This is something that would probably be useful for you. Slides of this presentation are available as well to print. There is a listing there for professional development hours, a PDH state information guide. Right now we offer PDH for 32 states, and that's where you would get information about your state to see if it's covered and what the requirements are. there's also a link to the Verantis EDU webinar page. This is our last live webinar of 2016, but we have 5 additional recorded versions that are available on the website that you can go back to at any time, and you can still get the PDH credits for it. We also have some additional webinars. They don't offer PDH credits, but there's some interesting topics. You might find them useful. So feel free to go in there, check out the archive. Along the bottom of your screen are widgets. I'm not going to go over each one of them. If you hover over them, it'll pretty much tell you what they do. There are some options there, though. We'd love to have you share this webinar via social, or if you want to email it to one of your friends, feel free to. There's also a link there that you can email us directly if you have any questions. The 2 most important widgets for the PDH portion are the last 2, and they are the test and the tracker widget. So if you take a look at the, let me see. I'm sorry, actually it looks like it got mixed up. It's the yellow widget and the green widget. So the yellow widget is your tracker widget. It's going to tell you if you've had enough minutes to complete for the webinar portion, as well as if you've gotten 8 out of 10 correct. And it's also where you're going to come back to print out your certificate once you have completed all the requirements. The last widget is the quiz, and that's where you're going to take your test at the end to see if you qualify for the PDH portion. So as an overview, today's webinar is worth 1 PDH professional development hour. You have to be present for at least 50 minutes. This is both for the live or the on-demand version. If you get interrupted or you need to leave for whatever reason, you can always come back to the on-demand version later on after it's been archived and complete whatever it is you missed. You must complete and pass 8 out of 10 of the quiz questions. Once you are done, go over to that yellow tracker widget and print your certificate. You have to, again, remember you need to meet all the requirements to do that. The printer's little button will not show up unless you've met all the requirements. If you have to come back at some point, you didn't finish it, you can come back and print the certificate later, or maybe if you lose it. I suggest you keep a log of everything that every webinar that you attend. There's a lot of states out there that offer spreadsheets that you can use. We will keep these records on file for 6 years. And then basically, if you have any additional questions, contact me, please, directly. And without further ado, I'm going to pass this on. Oh, actually, we're going to do our first poll question. So I have experience with fan installation, fan maintenance, both installation and maintenance, or none of the above. So we'll give you a couple seconds here, and then we're going to pass this on to Craig after we get the results. Okay, let's see. Good, we got about 50% who have done both installation and maintenance, but we've definitely got a few that this is a new topic for them, so glad that you're all here, and I think you're going to get something new out of this presentation regardless of whether you've done it before or not. So we are going to move on now for Craig.
Well, thank you everybody for joining us. We understand your time is valuable. You know, we'll make this next hour be pretty informative, and hopefully you guys walk away with something. This presentation, we're going to cover a handful of topics. The first topic that we'll get is fan components and accessories, and then we'll get into the receiving and inspection, basically what you should do once you get the fan on your site. Then we'll talk about the handling and storage, both short-term and long-term storage. Then we'll get into installation. We'll do startup, do monitoring, as well as maintenance. And so basically everything from routine maintenance to other types of maintenance that you'll see. So let's kick things off right now with the components and accessories. So you can have a fan set up in a handful of different arrangements. Basically, the first arrangement you see, arrangement 1, that's the arrangement without the motor, or the motor is going to be installed on a separate pedestal or a separate base that's not integral to the fan. So next to that, you'll see the motor positions, everything from a W arrangement all the way up to a Z, and basically that the shaft and the pulley are going to be in line with the motor. The shaft of the fan and the motor shaft are going to be in line. It's just a matter of where we put it within the position of the fan. The next one you'll see is arrangement 4, and basically what that is a direct drive fan. So that is where the motor of the fan is directly coupled to the shaft of the impeller. And arrangement 8 is an inline arrangement where the fan base is extended, and we'll use a special coupling for that type of arrangement that arranges that hooks up the motor shaft to the shaft of the fan. What you notice the difference between arrangement 4 and arrangement 8 is that the arrangement 4 has no bearings in the arrangement, whereas arrangement 8 has an inboard and an outboard. The arrangement 9 is where the motor is attached to the base. It can be either on the left-hand side or the right-hand side. And then usually that the motor sits on an adjustable base to properly tension the belts. And then in arrangement 10 is where the motor is actually it's actually inside of the base, and it sits on an adjustment plate. There are obviously limitations with an arrangement 10 based off the motor size, and that's typically when we change to an arrangement 9 or a 1 style where the motor is off on a separate pedestal. So what we like to do, especially for some of you novice people out there, we like to show an exploded detail of a fan. This is an arrangement 10 style, so this is where the motor is going to sit within the base itself. And so this kind of shows how all the bits and pieces go together. So let's start off right in the middle with the actual base itself, and let's look to the left of the base. So there you have the motor, which is sitting on top of an adjustable base, which will raise up and down. And then you'll actually see the drive set. So these are the shivs. So you have a motor shiv, and then above that you will have the shaft shiv. And so those get held together by a bushing, and then the belt goes around it, and that's how you actually turn the impeller. So all that stuff gets mounted to the base. The inboard and outboard bearings get put on the shaft. And then with that section, it has this particular arrangement has a canopy, which is an OSHA canopy, which covers all the rotating pieces of equipment. So basically the shaft, the pulley, the belt, all that good stuff. And then the actual housing and the impeller get put together all together in the fan. So with the impeller, it's inside the housing. There's a back plate and a gasket that get put on the housing that attach to the base itself. There's a couple different seal arrangements we can do. This particular design shows a Teflon seal, and then once everything gets put together, the fan gets test run and started up and shipped off to its end location. The next slide is an arrangement 9 style fan. And so it's basically all the same components except where the motor is located. So the motor in this case is located on the side, and it sits on top of an adjustable base. And like I said, that's what keeps the tension on the belts. So instead of having a canopy in this type of arrangement, we actually have individual belt and shaft guards, which are all mandatory by OSHA and are typically painted bright yellow. The belt guards, it's a guard that has expanded metal around it, so we can't get any can't reach inside of it without actually turning off the equipment. Junior, anything else you want to add with the two types of arrangements?
No, the only main thing I would like to add is the screen that goes on the belt guard is actually 304 stainless steel, so there is significant corrosion resistance with that as well.
So let's continue our discussion on components and accessories. So there are a handful of accessories that we can supply with the fan, and that are typically supplied with the fan. So number 1 and number 2 are flex connectors. Number 1 is the inlet flex connector, and number 2 is the outlet flex connector. The difference between these two is that number 1 is a slip fit style flex connector, which will basically connect plain round duct with a plain round inlet, and these are held together with stainless steel adjustment bands. And then the number 2, which is a rectangle in this case, outlet flex connector. This is flanged, so it'll attach to the flanged outlet as flanged duct, as well as the flanged outlet of the fan. Yes, you can do flanged inlets. Yes, you can do plain round outlets. You can do all sorts of different types of flex connector arrangements. This picture just shows the difference between the two. Number 3 is an access door. So access doors can be a couple different setups. This particular one in the picture is a bolted access door, but we've done toggle clamps. We've done hinged. We've seen a bunch of different style of access doors. And it's pretty important for inspection purposes. If you ever have to do any repairs, it's just an access port to the inside of the fan. Number 4 is the belt guard we talked about on the Arrangement 9 style fan. And what you can't see is the actual shaft guard on this picture, but anytime there is a belt guard, there is inevitably going to be a shaft guard that goes with this. Number 5 is the motor, and that motor is sitting on an adjustable base. And then number 6 is the actual housing that the impeller lives in inside of the fan. So we've got a few more components. Number 7 is the canopy. So this is a weather canopy, and like I said, it captures both the belt and pulley and motor system, as well as the fan shaft. What we don't see in here is a drain. Most fans come with a drain. It's basically, so if there's any built up moisture inside the housing, it has a place for the water to go, and you don't and your fan isn't treated like a pump. The water can actually go out somewhere.
Craig, can I interrupt 1 second?
Sure.
With the drains on a fan, they need to be properly trapped. If they're not properly trapped, you can end up with water buildup inside the housing, which is eventually going to start causing some erosion as it's beat around inside the fan.
Thank you. The item number 9 is the base or the bearing pedestal, and basically every style of fan is going to have some type of base arrangement. The number 10 is the outlet rectangle flange that we saw in the previous picture. Like I said, the outlet, it doesn't have to be flanged. It can be a plain round. We can put a transition on it. There's basically anything to suit your needs on the job site. Number 11 is the drive set. So there's your motor and shaft sheave with the belt. And then number 12 are the bearings. So there's your inboard and your outboard bearing along with the shaft. So a few additional components and accessories. We've talked about the flex connectors. So yeah, there's inlet and outlet flex connectors. The picture to the right shows a closed coupled fan with actually a piece of air pollution control equipment. So that is held together with a plain round slip fit onto the APC equipment, and then inlet dampers and inlet control vanes, as well as outlet dampers. The dampers, there's a bunch of different arrangements. It can be everything from an actuated damper to a quadrant locking damper. The key is just to make sure they're open and you don't operate the fan with them closed. Otherwise, you have a significant heating issue that occurs within the housing. Some additional components and accessories are for acoustical treatment. You can have anything from integral insulation built within the housing, which are the two pictures on the bottom that actually shows insulation built within the FRP housing, to sound blankets, to sound enclosures, to outlet silencers. There's a bunch of different ways to achieve your sound loading that you need, either for the job site or to be a friendly neighbor. So, all right, now that we've got the components out of the way with the fan, what should you do upon receiving your fan on the job site? So, the number one thing you need to do before you even take it off the out of the crate or off the truck, if you can do it then, is to check for damage during shipment. Fans should be inspected immediately upon receipt and before any attempt is made to unload. You can visually inspect for signs of damage, breakage, or abrasion. Check for loose banding or damage on the shipping crates. Now, it all depends on how the fan is shipped. You know, sometimes a larger fan is maybe just be on a standalone crate that's bound down to a trailer, but other times some smaller fans are actually shipped via LTL. So they may be dropped off at a bunch of different shipping points before it actually comes to your end location. So we need to check the ends, the top, the sizes, any protruding parts such as flange or nozzles for evidence of damage. Specifically for like a fiberglass style fan, you should look for impact damages where this is whitening of the surface or a star-shaped crack or crazes have occurred. This damage may be contained just to the exterior and could be superficial, but it's still worth noting. And then before you take anything out of the crate, turn the wheel by hand and see if it rotates freely and isn't bound up. If it doesn't rotate freely and it is bound up, you may have an issue where the impeller had shifted during the shipment, or the actual shaft may have gotten bent of some sort. But always with every fan that we get, any fan that you get on site, read the IOM manual. Don't throw it away. It's always some good information. And if any parts are found to be damaged, a claim should be filed immediately against the freight carrier. That's once the fan gets installed, there's not much you can do about it, and you want to make sure this thing is properly functioning by the time you get to that point. So, handling the fan, how should I pick this thing up? So it's pretty simple. If it's inside of a crate, you can just use a forklift or a tow motor or something to lift it up. But if it is out of the crate, fans should be lifted by the base, mounting supports, or lifting holes. If you order a custom fan, it may include lifting lugs or lifting eyes, so you can properly pick it up that way. By all means, do not lift a fan by the housing, the wheel, the shaft, the guards, the motor bracket. These are all important components that are key to the operation of the fan. If any of these components are compromised, you run the risk of a failure in the field. So definitely handle these things properly. They're pretty robust pieces of equipment, but they still need to be handled properly. Storage requirements: if you're not going to be using your fan for a lengthy period of time, the fan should be protected from weather and stored in a protected, clear, dry, and warm area. Always refer to the motor and bearing guidelines within the manual for further storage requirements. Most fans will have not only the fan operating information, but also the standalone components like the bearings, like the motor. Sometimes there's some information on the belts in there. Just feel free to review it. There's always some really good information in there. So, like I said, there's two different types of storage. There's short-term and there's long-term storage. So, with the short-term storage, routine maintenance is key, and you've got to do it at least once a month. So, re-inspect the protective devices. Check for scratches to the finish to make sure nothing had run into it or have taken an abrupt hit. Check all bearings and motor lubrications. Rotate the wheel by hand and redistribute the grease on the internal bearing parts. Typically in the manual there will be instructions on short-term and long-term storage. With the long-term storage, basically longer than 6 months, the routine maintenance needs to be performed once a month, just like we talked about for short-term storage. At the 1 year of storage and every 6 months after that, check for condensation inside the motor by following the manufacturer's procedure. If you can, hook up power and run the motor for 15 minutes to redistribute all the lubrication within the motor itself. That'll also redistribute some of the bearing grease as well. Also, just like I said, I can't say it enough, but see the manufacturer's operating manual. There's going to be some information that I'm sure I've even left out of this presentation that is going to be very specific for your model of fan that you have. So here's a sample storage instructions. Definitely, by all means, go ahead and review it. Print out the slide. It gives some information on 1 year storage. What are some items to do? 2 months of storage, up to 6 months of storage, 1 year storage, and then every month after 1 year, and so forth. There's some good information in there that we had talked about, but it's a nice reference slide just to have at your disposal. So all right, I've got this fan. We've received it. Everything checks out okay. What's the next step? How about we install this thing? Let's put this in the field and see what we can do. So with installation, there's going to be a fan inspection. You've got fan mounting. You've got duct connections, electrical connections, bearing lubrication, shiv alignment, belt tension. All of these things are key to go through before you put this fan in service. There's a nice little checklist right next to you that goes over some of this information. It's great to have before you start up a fan. Go through the checklist and make sure you hit everything. We'll dig into each one of these line items a little bit further, and that's what the next handful of slides are going to do. So, all right, with fan inspection. So you've checked the fan for damage during shipment. The fan, make sure the base is not twisted or misaligned. Check all the bolts for tightness. And make sure this impeller rotates freely. So it's basically taking all of your shipping and receiving inspections to the next level. Yeah, the fan OEMs, we've got we keep all of our bolts tightened, but some stuff breaks free during shipment, and it's worth just making sure all of that stuff is checked out accordingly. So fan mounting, this is super, super, super important. So you want to make sure the fan is properly anchored. The first step of doing this is ensuring that the fan is level. Ideally, you want this fan to be level on a concrete pad with anchors. We don't want these fans mounted on all thread that are supported in the air. We definitely want this on a base. We have seen occurrences where a fan has been mounted on all thread and is not on a secure level, and what happens, the fan starts vibrating and has the potential to damage the actual base itself, and then you've got issues get compounded and become a greater issue, and ultimately you may have to repair or replace the fan. If you have a concrete pad with anchors, sometimes vibration isolators are mandatory for the particular location that you're installing. There's a whole bunch of different vibration isolators available. There's rubber mounts, there's spring mounts, there's even just isolated pad that you can set your fan on. Those particular pictures, both fans on the slide show rubber mounts. So installation with duct connections. Ductwork or stacks should be self-supporting and independent of the fan by flexible connector. We have had it where a stub stack is placed on top of a fan, but the fan housing and base are designed to support that weight. Typically, a fan is not designed to support the weight of the ductwork. So that's why you put flex connectors in there. So if there's an issue with the ductwork, the fan is operating freely of what happens with the duct. So definitely put flex connectors on the inlet and the outlet of the fan to ensure proper system resistance. Electrical connections, motor wiring. Follow the motor wiring on the nameplate. We have seen occurrence where we have a backward inclined fan that the motor was reversed in its wirings and turned into a forward inclined fan. Yes, it's still going to move air, but it will not move what is required of the system. So make sure your wiring is proper, as well as the motor disconnect switch. What good is a motor disconnect switch if it's not wired properly? So definitely items that you want to make sure are done properly. So with installation, we want to make sure the bearings are lubricated properly. So fan bearing lubrication, it is typically a lithium-based grease, so an NLGI grade 2 style of lithium grease. Bearing surface temps can reach anywhere between 40 degrees Fahrenheit all the way up to 180, and then some. A couple examples are BP Oil EP2, a Mobile Ronex MP, and then Shell Gaddis S2 V220. These are all great styles of lithium grease that we've seen in the field. And then motor bearing lubrication, this is typically a polyurea-based grease, so like a Polyrex EM, or something that is stated on the motor nameplate itself. Typically the motor will be, it will have exactly what type of grease is noted on the plate. Bearing failures due to lack of lubrication, we have seen that before, and we've seen it a lot. And it's, you know, if a fan is installed on the rooftop, you may not have the proper maintenance plan for it. So what happens? The fan stops running or starts vibrating. Why does it vibrate? Because there's a failure due to lack of lubrication within the fan. So just by adding lubrication to a bearing, the level is reduced from 0.5 inches a second to 0.2 inches a second after replacing the bearings. So definitely the bearing failure can happen if not properly maintained. So this next line about bearing lubrication, this is very, very, very important. Do not mix the different types of lubricant with that are required. So they have different bases, and it is not a homogeneous mixture. A lithium grease will not blend with a polyurea base, and there are charts online. There's a bunch of different material compatibility lists available. So if you're using a type of grease that we're not discussing here, by all means, check out your material compatibility lists and see what you can mix with it. There are certain lubricants that can be blended together, but like I said, before you do it and just pull whatever grease off the shelf, make sure you have the right grease. Do not over lubricate. Excessive grease in the bearing can cause overheating. It will be necessary to remove grease fittings and permit access to the grease to escape. Like I said, if you have too much grease in there, that can be a problem, and you want to make sure that that situation is rectified. So, sheave alignment and belt tension. These are very important as well. Typically the OEM is going to go through this process, and everything should be checked out by the time it ships out of the plant. Most OEMs, they test run all their fans to make sure everything is in proper working condition. But stuff does happen during shipment. Stuff happens during installation. It's definitely wise to check alignment before you do any startup. There's a couple different types of misalignment. There's your vertical angularity, which is where the bottom or any of the sheaves are twisted. There's an offset, so that's instead of being perfectly up and down, we've got something moved over an inch or whatever, maybe moved over a certain amount. And then there's the horizontal angularity, so that's where, yeah, they're in line, but guess what? The angle, the pitch of one of the sheaves is not perfectly aligned up and down. So what happens when these aren't aligned? The shivs aren't aligned. You have belts that get worn out. You have a handful of different issues. So how do I align the pulleys? So there's a couple different methods. There's the straight edge method, or we can use a piece of string. There's also a laser alignment tool. Now, the most common is the straight edge or the string method, which basically when you lay a straight edge or a piece of string over the two pulleys, each of the pulleys should touch on two different locations. So basically on the left hand and the right hand side. So if you look at the picture in the top straight edge method, you'll basically see there's a little gap underneath the second pulley, the right-handed pulley. So that straight edge is not connecting on 4 different points. It's basically, it looks like it's connecting on 2 of the first one, and then 1 point on the 2 on the left, and then 1 on the right-hand side. And then same thing with the string method below. You see that the piece of string is perfectly aligned with the pulley on the right, but when you go over to the pulley on the left, it's only touching in 1 point. So it's pretty simple, pretty rudimentary. If you don't have a laser alignment tool, this is a great field measurement. So shiv alignment and belt tensioning. We talked about the shiv alignment. Let's get to belt tensioning. So you definitely want to check the tension of the belt. There is a belt tensioning gauge available that can be purchased at I think Big Master Car or Granger or any of these places have a simple gauge and should be adjusted using the motor slide bases. So most bases, most style of fans like an Arrangement 9 and an Arrangement 10, they do have adjustable bases on them, so it can get that the belt tension where you need it to be. New belts typically require a higher tension level than used belts. This is simply because of the fact that the belt hasn't been run in yet. But definitely check the tension frequencies during the first 24 to 48 hours of run-in operation, because it will change over a period of time. It's on the there's a couple different when you're doing routine inspections of the fan, you definitely want to always check for the tension. Picture below shows if it's too loose or too tight and kind of where it should be.
Yeah, during your belt tension, if you don't check it, they are set at the factory, but as Craig said, over time they will loosen because of the run-in time. If you don't retension those belts, it's going to start out, you'll see a black dust in the belt guard or under the canopy. Eventually those belts are going to continue to wear down and potentially even cause wear on the shiv, and you would have to end up replacing not only the belts, but the shivs too, if it's let go long enough.
Thanks. So there's a slightly different installation for axial style fans. Basically, there's rooftop versions, there's leg supported version, and suspended. So they a little bit trickier, but you still want to have the same principles where, especially for an inline style fan, you don't want it to be coupled directly to the ductwork. You want it to be on its own separate system. So that's why we use flex connectors on the inlet and outlet. Typically those are flanged flex connectors. On top of that, you can also do vibration isolation through spring hangers to make sure it's independently an independent system. So, all right, let's talk startup. We've got our fan installed. We've got all the checklists ready to rock and roll. So let's do startup. So prior to starting up the fan, inspect and confirm that there is no debris inside the ductwork or the housing. We definitely don't want a chunk of something going through the fan, because we may damage the housing or the impeller. Check all bolts, drives, and belt tension. Ensure all safety guards are in place. So make sure your belt and shaft guards are ready to go. Your canopy is tightened down. We want to make sure everybody working on a fan is safe. Dry the motor windings if it's stored in a damp location. And then check the fan for proper rotation or momentarily starting the blower. Like I said, that goes back to making sure your motor is wired up properly. We want to make sure it's spinning in the right direction. So check after the fan has been started. You know, all of these are checked typically in the field, but still check to see if the motor bearing temperature is within range and hasn't been elevated. Check the fan speed. Check motor voltage, check amperage, check all the bolts and belt tension after 1 hour. Do not operate the fan if excessive noise or vibration is present, and contact your OEM immediately. If a fan leaves the shop, they want to make sure it's good in your field, and definitely contact the OEM. So there's a couple different various types of monitoring available. The two main ones are vibration and temperature. So vibration can be monitored on the fan bearing or motor, typically done with vibration switches with transducers or an accelerometer. Temperature monitoring can be done on fan bearings, it can be done on motor bearings, or it can be done actually on the interior of the housing. Fan bearings or housings are typically an RTD style sensor, whereas the motor bearings are on either a thermostat, a thermistor, or an RTD sensor. With monitoring, we've also included motor disconnect switches. If a motor disconnect switch is required, make sure the NEMA rating fits your environment. If a NEMA 4 is required, or a 4X, or a 7, or a 9, the OEMs typically can supply these, but we just got to make sure it's the right rating for your environment. We don't want to have a hazard started by the motor disconnect switch. As for fan monitoring packages, please consult with your OEM's application engineers for selection and availability. They will be more than willing to help you out or provide something in this direction.
Craig, real quick, what's RTD mean? Had that here in the fan bearing housing.
It's just another type of temperature sensor. I'm not sure what the actual acronym stands for, but it's just another temperature sensor that monitors. It's not sure what the acronym stands for.
Okay. And I think we're going to move on to our next poll question here. Are you using any type of remote monitoring with your exhaust fans? Options are yes, no, but I sure wish I was. Give you a second here to do your answers, and then we'll see what everybody's saying. Okay, let's see what our results are here. Okay, about 30% of you are using some type of remote monitoring, 55% are not, and then we've got about 15% of you that are wish you did have something. So quite a few that aren't right now, and it's definitely something to consider. It's a valuable option for keeping your fans running the way they should and keeping on top of any issues before they happen. Okay, so next, moving back here to Craig.
And then with the help of Google, RTD is a resistance temperature detector. It's crazy. We've used them in systems before, and didn't have that at the top of my head, so I'm not going to forget it now. So let's get to maintenance. So we've got a routine maintenance of the bearings, shivs, belts, motors, and impellers. The rule number one of maintenance is to be sure that the main electrical disconnect switch is locked out in the off position. We definitely don't want anybody getting inside of the fan and having this issue where the power is not turned off. Most facilities have a lockout procedure make sure it's followed. That's the main thing. We don't want to hear of any issues happening with our fan that could have easily been prevented. So, routine maintenance, it should be performed after a couple hours, after 1 day, after 1 week, after 2 weeks, and then once a month thereafter. The routine maintenance, it includes inspection of impeller and hub connections, belt tensioning, set screw and bolt tightness, fan bearing lubrication, wear and overheating, impeller and housing buildup or overheating, and condition of housing and impeller materials of construction. So here's a couple bearing lubrication charts. Typically it's in the manufacturer's manual. So the first chart up top is for ball bearings, and then the bottom one is for spherical roller bearings. Basically, an example of the like a DLM style, which is
DLM style bearing is a ball bearing.
Okay. So let's look at the ball bearing chart. If I've got a bearing that has a let's just go 1 7/16 bore size, and it's running 24 hours a day. So what we'll do, we'll look at 24 hours a day. Typically, we know the fan is going to be running at let's just say 1,200 RPM. We know that it should be inspected once a week. So that's typically how that chart is laid out. Like I said, that should be in once you get your fan. It's in the operating maintenance manual, and definitely refer to that as to how often you should be looking at lubricating the bearings. So for bearing lubrication, most fan bearings are supplied with extended grease fittings or lube lines. If that is not an option for your new fan, make sure you let the OEM know. That way you don't have to remove the canopy or remove the belt and shaft guard, and you've actually got access to it right there. It just makes lubricating bearings after service that much easier. So bearing replacement, replacement instructions per bearing manufacturer's manual. There's 2 different styles that we typically see for bearings. There's ball bearings and spherical roller bearings. Now, if you are replacing, contact the OEM. Make sure they can provide you the proper one. If you've got overheating on the bearings, if you've got a vibration issue, that may also be bearing related. Junior, any other types of bearing failure type issues that come up? I mean, we've talked about not using the proper grease.
Well, proper lubrication. You know, make sure it's whether it's the NLGI2 lithium based, or if it would be a polyurea or clay, whatever your base is. Be sure to use the proper lube. Too much lubrication can cause overheating of the bearings, which in turn, if it's an excessive temperature, could cause the seals to be compromised and could let dirt and stuff into the bearing, which again would affect the bearing.
So also during inspection, you want to inspect the shivs. So basically inspect the shivs for sign of wear or rust. That picture on the left is a well-used sheave that's been in service for some time, but you can see it's rusted out and is definitely in line for replacement. Whereas the picture on the right shows a basically brand new one where we're looking at the grooves to make sure it's properly in line.
And groove gauges are available for your different shivs. Any shiv supplier, you should be able to purchase them through there.
So the next one, belts. Check the V-belt drive for proper alignment, just like we talked about at the beginning. Remove the belt of foreign material and wipe dry with a cloth. If belts are worn, replace them as a set and not individually. If you replace them individually, they wear at different periods of time. And then with the motors, keep the motor clean, keep the ventilations open. If you're in an environment that is going to be pretty dusty, definitely keep the vents clear. Spray some shop air or something on it to get the dust away. Keep motor bearings lubricated per the motor manufacturer's instructions. The maintenance on the impeller and hub seal. Basically, this is a picture of the hub seal detail. This particular arrangement has a single seal, but if you've got a different seal arrangement, review the seal. Make sure it's still doing what it's designed to do, and also check the bolts to make sure the bushings are still tightened. So with the fans, we've depending on what the material of construction is, you may see some heat distortion. So this particular photo shows an upset condition within the system that created a temperature spike, and you can see where this particular one is fiberglass, and you can see where the fiberglass is wrinkled due to a heat upset condition. It can be wrinkled. We've seen it where it's been scorched, where the outer layer of protective corrosive protection has been worn off. It's definitely something to look at. Typically, you're aware if you have an upset condition where a temperature spike has been seen. This also can go back to monitoring. If a damper is closed and the fan is operating, that heat has nowhere to go. So what inevitably happens is that there's a heat buildup within the housing and can be destructive in nature if not caught in time.
Yeah, as Craig said, if you see an impeller that you see this kind of wrinkling and cracking, or the bowing of the blades where they should be perfectly straight, do not run the fan. You're looking for a catastrophic failure to happen.
So it's wise to inspect the impeller, like I said, during routine maintenance or when the fan is off. So we have seen blade buildup. If there is a particulate environment that you have, there's a buildup can happen on the blade. And what happens is that there's an imbalance, and excessive vibration levels can happen, causing havoc on the fan. You can clean this though. Impeller cleanup and wash. We recommend you use a residential power washer. We don't want to be using a high pressure commercial washer because it just pit holes through it and ultimately get into the base layer of the housing or of the impeller, and you could lose the corrosive protection of the impeller. And we don't want to have that. Plus, you lose some structural integrity. So this photo shows some blade cracking, and this has been caused by probably a couple different things. There's heat distortion as well as abrasion and wear can cause these types of things. So in the picture on the left, you'll see where it's actually started to delaminate, where the different layers of fiberglass have broken apart from each other. Whereas the picture on the right shows more of an abrasion wear type situation where it's slowly getting into the surface of the impeller. And then the last thing you really want to look for is cracking, and this is if there is an imbalance due to particulate buildup or there's some other imbalance, and this impeller has been shaken so much that it can crack, and this is considered an impeller failure, and the impeller needs to be replaced and typically can't be salvaged at this point in time. So.
Thank you, Craig and Junior. That's a lot of information to cram into an hour, and sometimes you have to breeze through a couple things, but we're obviously open for questions even after this presentation. Before we move on to the questions, I do want to just remind everybody who is here for the PDH portion that you need to take the test, which is the last widget. Once you get 8 out of 10 correct, go over to the widget next to it, the left one that has the tracker. Once you've completed at least 50 minutes, which if all of you have been here from the beginning, you'll have that. And then have the test criteria done, you can print your certificate out there. If you have to leave, totally understand. You can come back as well and do this at another time. We're going to try and hit as many questions as we can right now. If we don't get to your question again, don't worry. We will answer it even if we have to offline. At the end of this presentation, the phone portion of it, our audio, is going to go mute, but we will keep the actual platform open until 1:30. That are actually another half hour. I'm not sure where everybody here is coming from, but Eastern Standard Time, another till 1:30 or another 30 minutes. That will give all of you a chance to go and print out any of the materials that you want, take the test, and just look around at other things. Email us if you need to. During that time, we will actually still answer questions. If you guys are online, you'll get an answer immediately or once we get to it. So moving on to the questions. Just give me a second here to pull a couple of them up. Our first question. Turns out real small, unfortunately, but it says, can FRP fans be repaired or is a replacement wheel recommended?
On an impeller, if we see severe cracking, which means there's been vibration levels present that causes the fan impeller to see stresses and forces it normally shouldn't see, we do not repair. They would have to be replaced. If it's something as simple as a little superficial material coming off, we may, but it would have to come back to the plant. I will not look at photos and determine if it can or cannot be repaired. I have to physically see it.
This is a question actually from one of the earlier slides. Explain proper trapping of the drain.
So basically, each fan is rated for a certain amount of static pressure, and to trap a drain, you have to design the drain trap to accommodate that pressure loss. So it's no different than like your plumbing in your house. It's got there's a trap within the sink. If you look underneath the sink, there's a differential in height that is required for a pressure that needs to be overcome. It's wise to consult with the fan engineer to kind of give you some guidance as to how much of the trap, how tall the trap needs to be. But there are I know we've done in the past where we've kind of set up what this needs to be for the job specific, or you may have an engineer on site, or you may have a plant foreman who has done 400 traps and knows exactly what he's talking about. But you can Google how to build a trap, and it's right there at your fingertips.
Keeping on the theme of the drain, can the drains drain while operating, or does the suction hold water in?
That would depend on if it's a push fan or a pull fan. If it's a push fan, which means there's positive pressure inside the housing, typically it would blow out the drain. But if it is a pull fan, you're going to be pulling air into the housing. Therefore, any moisture that's in there could potentially stay inside the housing.
But that also goes to proper drain trapping as well. So together, those will help you drain.
The belt guard screen is 316 stainless steel, but are other metal components also corrosion resistant?
Okay, the belt guard screen is 304 stainless steel. All of the bolting we use in our fans for standard is 316 stainless. Whether we're bolting down the bearings, the adjustable motor base, or any of the bolts that come through the housing, Everything is 316 stainless.
If you've got a specific location that you need some additional corrosive protection, heck, you could make a Hastelloy screen out of expanded metal if you needed to pay a premium for that. But yeah, it's basically expanded metal. So there's many types of metal that are corrosion resistant.
One thing to note is that the 316 stainless that Junior is discussing is a standard for us. It is not necessarily for Verantis. It's not necessarily a standard for other fan manufacturers. So that's just something you need to keep in mind when, if you're with somebody else's fan, it may not be. It may be just a carbon steel, or something else. Just keep that in mind. And
fiberglass fans are going to probably have different build specifications versus a plastic fan versus a carbon steel fan. So it really is dependent on where the environment that the fan is going in.
Okay, we're starting to run over time. We're going to do one more question here before we sign off. But again, just a reminder, we will get to you one way or another, either during this quiet time for the next 30 minutes, or we will contact you after the presentation. So one last question here. Can FRP fans obtain spark-proof, explosion-proof rating?
So with spark-proof, we can put a carbon gel and definitely hit a specific rating. As for explosion-proof, there are ballistic blankets that can be included. There are certain thicknesses that can be built within the fan, but to truly say it's explosion-proof. Now, if we're looking at, like I said, spark resistance as an explosion-proof, the motor needs to be specified specifically. We will test all of our fans for conductivity to make sure they don't transmit any electricity. Junior, want to add anything else?
No, typically though our fans on the interior would be coated with a carbon gel material. There is grounding lugs that are tied to the inside of the fan. The impeller is grounded to the fan shaft, which wouldn't turn ground out through the base and bearings. We have put additional grounding lugs, carbon brushes on the fan shaft. But everything could be tied into a grounding lug to bleed off the static electricity.
Okay, I think that's all we have time for today. Again, platform's going to be open for another 30 minutes after this. We're going to be going quiet, but if you have some additional questions, you can still use the Q&A box. You can also feel free to email after the presentation. We'd be happy to talk to you some more. Thank you again for attending today, and just a reminder, if you need some more education or some other requirements you need to fulfill, we have 5 additional webinars that are available at verantisedu.com, and we will have a full lineup for 2017. We probably will be offering between 8 and 10 webinars